TTL Computer 2. Today we'll be taking a look at our work to add fixed point math to TTL Computer 2 and to Pilot, our native programming language. Before we jump into that, let's take a look at a few updates to our monitor. And we can look at our command set here. And we can see that our command set is kind of shrinking. So we don't have as many commands as we had before, but we do have something new. So let's take a look at our a directory listing, and we can see that we're starting to add programs into our flash drive system. And what we can see is what I've done is moved some functions out of the monitor and added them to individual uh, individual external programs. We can see here that we have export. That was our export function from the monitor. Now that's in its own program. We have debug program, and that represents a lot of our functions from our monitor. That was the more monitor type of things, the hex dump utility, the ability to fill memory and to modify memory. Those commands have all been taken out of the monitor and put into our debug program. Also have format.r, which is a proper flash drive formatting utility. So now we have a way to quickly and easily, format compact flash drives for use on TTL Computer 2. And then we have Pilot and some Pilot games and things. So that's what our flash drive is looking like now. Okay, so we want to get into Pilot and we want to look at our progress for fixed point math. And what we're going to do first is we are going to load our fixed point math test program, which is mathfp.p, and that's loaded into memory. And now we are going to run Pilot. We're going to use a new command, our execute command, and we're going to just say pilot.r is what we want to run, and it's going to load that and automatically execute the program for us. Jump right into the program. Okay, now since we loaded our math fixed point test program first, that's in our pilot memory, and we want to do a warm start. So we preserve that and take a quick listing, and we can see that that in fact is there. And let's give this a run. Okay, so what we're looking at is our substantially the same math test program as we used to look at our signed math before, which was integer math. So now this program has been updated for fixed point. So the prior program used integer variables, and this version of the program is using fixed point variables. So we're going through our little subtraction exercise here from 5 to -5, but you'll see that we're, instead of subtracting 1, we're subtracting 1 1/4 each time. So 5, 3.75, 2.5, 1.25, right? 0, and -1.25, right? -1 1/4 each time, all the way down to -5. Right, so that's just demonstrating our um, fixed point subtraction. Let's continue now to multiplication. So now again, our same multiplication as we did before in integer, but this time in signed fixed points. And we're starting at 5, going starting it with -5 squared is 25, and 0.000, and now we're subtracting 1.5, I suppose. So we're down to -3.5, or adding 1.5. And that's 12.25 squared -2 times -2 squared is 4.5, minus 0.5 times 0.5 is positive 0.25, and 1 is 1, right? 2.5 squared is 6.25. 4 squared is 16, and 5.5 squared is 30 1/4. So we can see that our signed fixed point multiplication is in fact working. Okay, now we go to division. So we can see how we're doing substantially the same division as last time. Again, we're adding 1.5 each time. So 100 divided by -5, -20. 100 divided by minus 1.35 minus 28.562. Now, this is not exactly correct. So all fractional representations, all fixed point, floating point representations in a computer are approximations. And we know that if we take 1 and we divide that by 3 with any of our calculators, we get 3.333333. And if we square that, we don't get back to 1. We get to 9. We get to 0.99999. So fractional representations are always approximations. And so this properly should be 100 divided by 3.5 is 28.571. So we can see that our approximation is a little bit low. But we'll take a look at our fixed point representations in a little bit more detail in our next video and what that means for us in our pilot programs. But that's a pretty close approximation. And again, we're targeting game development here, not doing a math calculator on TTL Computer 2 or with Pilot. We're looking at game development. So, and this is sufficient for us for games. And then 100 divided by minus 2 minus 50. 100 by minus 0.5 minus 200. 100 by 1, 100. 100 divided by 2.5, 40. 100 divided by 4, 25. And then 100 divided by 5.5 is in fact 18.125. So we see that we have our signed fixed point division is working. And continue. Now we finally look at our comparisons, our fixed point comparisons. So we can say, I don't know, let's do minus 10 compared to, how about minus 5.5? Okay, and in fact, right, minus 10 is less than minus 5.5. Do another comparison. Let's do 0.375 and 0.250 in comparison, and 0.375 is greater than 0.250, and they are not equal. And then, I don't know, one more final comparison, I guess. Let's do about 5 versus 5.0, and they are in fact equal. Okay, so that's it. So that's a basic look at our addition of fixed point math into TTL Computer 2 and to Pilot. And that's just important to note here that we're not only doing fixed point math now, right? TTL Computer 2 still supports integer math in addition to the fixed point math that we've just added. And we can use those together in formulas, and we'll see that in our next video as we take a more deeper dive into our fixed point support and again what that means for us in TTL Computer 2. But that's it. Until next time, thanks for watching.